Hello. So today we are doing this problem called word pattern. So the problem states that we get a pattern and a string, and we want to find if a string follows a pattern, basically. And so follows here means that it's a full match, such that there is kind of a bijection between letter in pattern and the non-empty word in the string. So the pattern is a list, a set is a word, so it's kind of letters, and then the string is a list of words that are separated by a string containing a list of words that are separated by space. And the mapping, for example, in this case, is from A to dog and from B to cat. And we can see A is here, B, which is cat here. And then when B happens again, we have cat. And when A occurs again, we have dog. Same thing with the rest of the examples. And we can assume that parents is only lowercase and that string is also lowercase, separated by a single space for between each words. Okay, so we are going to solve this problem in multiple ways. So let's first start with the simplest one that is just a brute force way of doing it. So first thing we are going to do is just split by space. After that, we can check if so the first thing is if the length of the pattern is different than the length of the word, then right away we know we can't find a bijection. The other thing is also if the set of unique characters of pattern, the number of unique characters of pattern is different than the number of unique words, then that means also that we can't find a bijection because basically there are more elements either here or here, so we can't map each one of them to each one to the other. And so in these cases, we can right away return false, right? The other cases, what's left now is just to check that each occurrence maps. So we know after this, we know that they are the same length, and we know they have the same number of characters, of unique characters. Now we just need to check that it's really something like for ABA, it does really map to cat, dog, or something like dog, cat, cat, dog. So we kind of need to check that A maps to dog for all of its occurrences, and B maps to cat for all of its occurrences. And so the way we can do that, we can just have a map, and then we can go through the letters of pattern, and check if a letter is not yet hasn't yet been added to the map. Then we can just do the bijection, like said that letter is mapped to the word at I. Now otherwise, which means it's already has been encountered and has been mapped, so we just need to verify at that point. So we just need to verify that the letter, so if it's not equal towards I, that means this mapping is different than the new mapping that we found. So that means we can return false right away. If we went through all of them and we didn't find such a case, that means there is a bijection because all of them have the same mapping. So we can just return true here. Delete this and let's run this. Okay, so it passes there. See here. Uh-oh, we have. What happened? Yeah, so it should be this actually. Okay, so that passes. Now let's try to write a shorter solution here. Instead of doing this, instead of doing all of it like manually with the for loop, we can just do it with a map. So what we can do here is just map basically. So what we are going to do is map pattern. So we are going to find each letter, the index of each letter in pattern, right? So this gives us basically the first occurrence of the letter in pattern. And then we are going to find the value for each letter in pattern, right? And then we are going to also, so let me first just put it this way. So before doing the return. So here, this will get us the indices of occurrence of first occurrences of each letter in pattern. And then we are going to do a similar thing, except since it's a list of words, we are going to find the index for each word in words. So this will give us the indices of first occurrences of each word in words, right? And now if these indices lists are equal, that means basically that we have a bijection, right? So we could just return. Let me do it on an example here. So let me say, let's say pattern. Let's take pattern, for example, equal to this, and let's take str equal to that. Okay, and then let's have the words here. So words now is just the list of these elements. Now, what is map of this? So this gives us the index of, for A, B, B, A, give us the occurrence, the index of the first occurrence of A, which is 0, of B, which is 1. The index of occurrence of the first occurrence of B is 1, and of A is 0. Now for the words list, I made a small mistake here. We are looking for it in words actually, and not in pattern. So let's fix that. So this also gives us the index of the occurrence of the word in the list. So here, dog, it's the index of its first occurrence is 0. Cat, the index of its first occurrence is 1. Cat, the index of its first occurrence is 1. Notice it's not 2, it's 1 here. Same thing for dog, the index of its first occurrence is 0. And since these two are equal, that means there is a direct mapping, bijection mapping here. If this was something else, then the value here would have been different. And we would have detected, by checking if they are equal, we would have detected that it's not, there is no bijection between the two, right? So we could just check these two. So our return would just do list, check that the two lists are equal. I should not have submitted. Okay, so it says false. Yeah, because this is a list and this is a map. So basically, this here, you can see it's an object. So we need to have list here. Okay, now it should. Okay, now it passes. Okay, so this solution here, we could write it in a shorter way. So instead of doing lambda x parent.find x, we can just do this, just omit the x entirely, and this should work. Same thing here, we could just omit this and just say apply words.index. And this works. It should work. Yeah, so this works too. Another way also to avoid this a little bit, just it's a little bit ugly to have list and then map. We can just use list comprehension. Instead of doing list map, we can say we want pattern find x for x in pattern, which does the same thing. And then instead of doing this, we could do words.index w for w in words, right? So this also should give us the same thing. And if I submit, should pass. Yeah, cool. Okay, so another solution that is very clever. Just before doing that solution, I need to explain something called set default on map. So basically something we are used to do usually is for a map, we set it and then we check if key in map. Say, for example, we have a map that maps like key to list. What we are used to do is checking if the key is in the map. Then we do, if it's not in the map, then we do map key equal to list val, say, for example. Else, we do usually key that append val. So we want to initialize the list first, or we could, another way of doing it is to say if it doesn't exist, create an empty list for it, and then after that you can append for both cases. So there is a way to avoid like writing this if else thing, and that is with set. So if I have a map like this and I say set default of some key, let's say A to 2. Let me instead do it for, okay, let me do it with a list so I can just have the same example. So let's say for A, it's, if I do m.setDefault for A as a list of this, so M now contains that. This basically means check if A is in the map. If it's not, then add it with the value this. And if it's already is in the map, do nothing. So now that we have A already in the map, if we change that and set something new, it will stay the same. So A is still mapped to 2. So it only sets it if the key doesn't exist in the map. So even if I do, it sets it only if the key doesn't exist in the map, which is kind of what we wanted. So we want to only set the first occurrence. We want to only have the index of the first occurrence. So that means we can use set default, which will set the index only the once. And so we will have only the first occurrences, right? So we can use that here by doing, so let's have a function here that takes a string and returns a map that applies. So we can just have the map and use set default. So we are mapping set default of a map on all the content of whatever string we have here. And what are the values? So the second parameter here, so basically map takes the function, which for our case here, it's set default, and the parameters. And our parameters in this case are the key and the value. So map will take each time an element from S and makes it the key, and then takes each time the element of whatever is here and makes it the value. So what do we want here? We want the indexes. And so to get the indexes, we can just do range of the length of this S, which will be 0. So this will give us 0, 1, 2, 3. And so we will first set the first character to 0, the second to 1, the third to 2, and that's basically gives each character the index. Except with this set default, we will set it only once. So if we do that, then we can just check that applying F to pattern is the same as applying F to words. So this will make sure that the lists of the first occurrences of each character and of each words are the same here. Let me apply this so we can see. So let's have F be this function. So if I apply to ABBA, let's make it a list. So you can see it gives us the first occurrence, the index of the first occurrence of each character. If we apply it to the other value, which is dog, cat, dog. Yeah, so it's a list of words. That's what we are using. It's not. So it gives us the index of the occurrence of each word here, right? So we can just compare that these two are equal. Only one thing to be careful of is in Python 3 maps, you can't compare the maps because they are objects, so we will need to have a list here. And this should give us good result. Yes, okay. So there is another solution, another additional solution that we can do, which is so with this solution, let me write it down. So let's just call this T, and let's call pattern S to simplify things. So what we are going to do is, if we do, let's say S is equal to this, and T is equal to this split, which is what we are doing here. So if we zip S and T, what do we get? So we get this. We get the, like, mapping each character of S to that of T. Now, if we make a set here, we get all the unique mappings, right? So we get, and discard the duplicates. And then if we do this, we get all the unique of S, and if we do this, we get all the uniques of T. So what we essentially want is, we want this, the length of this to be equal to the length of this to be equal to the length of this. So basically, if we do this, we will guarantee that there is no unique element in S that is not in T, which will, because if that exists, then we no longer have a mapping. And so we can guarantee that with this first, with checking the length of this equal to the length of this equal to the length of this. The second thing we need to guarantee is that we don't have something like A, B, A, C, and then the same value for cat, which is cat, dog. So here there is a mapping between this and this, but we have one extra thing here, and we don't want that to get counted. And so we can also compare the length of the two, the length of S and the length of T, to be sure of that. So we can just enumerate all the cases that make the mapping happen, basically. And so we can return here the length of the set of zip S and T equal the length of S equal the length of set of T, and we want also the length of S to avoid this case equal to the length of T. And that's about it. And the solution passes. Okay, that's it for now. See you next time. Bye.